Good morning, Mustangs. So I got a little story to share with you. My wife always compares me to Zac Efron. She'll sometimes look at me and just go, "You're nothing like Zac Efron." What can I say? Anyways, hi. So today in our lesson, we're going to be working on transformations. And the notes that are actually on Schoology, I'm going to stray from those notes, but I will actually post an answer key to the notes. Instead, I thought I would just use this time to do more of a visual representation of all transformations that we actually see taking place when we're looking at graphs and the whole process behind how to actually do these. Okay. So, first off, I'm going to start with what we call rigid transformations. Okay. Rigid means that the shape itself does not actually change. So, it's rigid, it's stiff. And so, what we're talking about when we're doing rigid transformations is we're doing the basic up, up, down, left, right, reflecting. But that's it. We're not doing any stretches or shrinks. Okay. So what do all these look like? Well, in all of our shapes, what we do is we start with the parent function. So when we look at this parent function right here, this is the parent function for the square root of x. Okay. Now, when we're doing the square root of x, it's just starting from 0, goes up in the positive direction, and that's because we can't have negatives because we go into the imaginary region, right? Well, if we look at the first one to the second one here, let me actually put myself over here so I can point to things, okay? So right now we're looking at, that's the parent function right there. And now we're going to look at this one right here, which is going to take it, and if we do plus 2, I want you to remember that when we say y is equal to, that's the same as saying f of x is equal to, that the function is equal to. So when we look at this second one right here, what we're saying is whatever my y value is, because remember up here it says that y is equal to the square root of x. This function says we're going to take the y value, whatever that function looks like, and we're going to add 2 to it. And by me adding 2 to the y value, we're causing it to shift up 2 because we're moving in the up and down direction when we're changing the y value. So this is what happens when we actually go up 2. Okay? Versus when we take a plus 2 and we look at it on the inside of our quantity, anytime we're grouped inside with the x value, we're affecting the x value then. So when we look at this third one right here, what we're doing is we're taking that x plus 2 and we're saying, let's change my x. And by changing my x, let's go ahead and do plus 2 to it. So we're saying we're going to modify my x by 2, and it's going to be to the left or to the right. And whenever we're doing these are actually counterintuitive. So whenever it's inside a quantity, we actually take the opposite of what we see. Why is that? Well, the general form of these is actually x minus the h value. Okay, so when we look at this, we're saying x minus the h value. Let me see if I can throw one in here. Y equals the square root of x minus, let's throw an h in here, and then we'll add a slider for h. And what you're going to notice here is as we go ahead and shift the h value, the formula is x minus h. When h is 1, you'll notice that what, I got to change this color so you can actually see it. Let's make it green. Okay, so the green one is the new one. Okay. When we take the h value and we make it equal to 1, you'll see it actually shifts to the right one. But there was that minus in the middle of this right here. So now when I make it equal to a negative 1, okay, well, if h is a negative 1, it causes a shift to the left one. And what happens is when you take the negative h, the negative 1, and you put it with the minus h, x minus negative 1. So in our eyes, that's going to be looked at as an x plus 1, and because of that, it ends up looking like a positive 1 to the right, when actually it's a negative 1 to the left. Okay? And so we could just sit here and play with this. You could see that what ends up happening, oh, that went way too far off the picture. Let me zoom out so you can see it. But what's happening is as we go negative with it, it goes to the left, and as we go positive, it goes to the right. But again, that's the opposite of what we're going to actually see inside the function there. Okay? All right, let's shift on to our next one here. The next one we're looking at is this y is equal to the square root of negative x. So think about what this means. When we have the square root of a negative, when we have a negative square root of x, sorry, we're looking at this one. When we have the square root of a negative x, my apologies. What I'm saying is let's take the opposite x value. And so when we take the opposite x value, whatever value we have on the right side is not going to reflect over to the left side. So that means that when we're looking at my picture here and we look at this spot right here where we've got actually I could just make the point, what am I doing? When we look at this, we've got a point right here. Oh, it's not letting me do it. But we've got a point over here at 1, 1 right here, okay? And if I was to take that x value, because I started at 1 right here, and what's going to happen is it's going to reflect over, because we're taking the opposite x value. We're going to take opposite of 1 is going to give me a -1. It's going to reflect me over the y-axis. And so if it reflects over the y-axis, what does this look like? Well, let's take it and reflect it. Every point that went to the right now goes to the left instead. Okay? All right, let's look at the negative square root of x. What's happening with the negative square root of x is we're saying take the opposite of our function, meaning take the opposite y value. And so every point that we look at in my picture that's in a y direction, we're going to take the opposite. So that means that if I have a 1 right here, and I'm going to take the opposite y value, because this is a 1 right here, opposite y value of 1 would be down here at a -1 if I don't change my input. So what this will cause is a reflection over the x-axis. So a negative attached to x means we're going to reflect over y, and a negative attached to y means we're going to reflect over x. Okay? So now let's kind of start put some of these ideas together. When we look at number 6 right here, your brain is going to see this and think, well, we're going to take the opposite x value and we're going to shift to the right 2. So if I take the opposite x, what's going to happen is I'm going to reflect it over the y-axis, and then it's going to shift to the right 2. I'm sorry, to the left 2, because that +2 that's right there. So it's going to reflect over the y because of the negative, and then shift left 2. And here's what happens. Oh, I can't do it on there. I'm going to do it on here. So we said it was going to reflect over the y. We see a reflection here, but we said it was going to shift to the left 2. But it actually shifted to the right 2. Why is that? Well, that's because whenever we're talking about reflections and left and right shifts, we cannot do the left and right shift until the x is isolated. So when we look at this one right here that I'm circling, the x has to be isolated first. That means that whatever is attached to my x, no matter what it is, always factor it out first. So in this case, I'm going to factor out that -1. And what's going to happen is that -1 is going to cause the reflection. And then right here, you see how it says -2. That means it's actually going to go to the right 2. And so when we click on that, you'll see that the blue now covers up the black. And that's actually the exact same function. Okay, you can see that? So whatever's in the front of x, always factor it out. Okay? And the other thing is, how do we know the order? Which way do we actually do this? Do we do the shifting first, or do we do the reflection first? A saying that I like to use is always reflect on things in life before you act on things in life. Okay, so always reflect on it before you act on it. I can do reflections anytime I want. I can do stretches and shrinks anytime I want. But I have to do the left and right shifts and up and down shifts at the end. Okay. Let's look at the next one here, number 8. Oops, just moved that where I didn't want it. If I put a negative in here, what's going to happen? Well, we think about the fact that that negative is attached to y. So we're going to see that orange line reflect over the x. And then we're going to see it shift up 2. Okay? So reflect over x and then shift up 2. That's it. These are all of the non-rigid, the rigid transformations, meaning the shape itself doesn't change, it just moves. Left, right, up, down, reflecting over x, reflecting over y. That's it. Well, what about non-rigid transformations? This is the one that's a doozy for people, okay? I'm going to take an absolute value function, and I'm going to go ahead and I'm not going to talk about what's happened to x or y. I'm going to show you a visual of how crazy this looks, okay? If I take the absolute value and I graph this, here's what my graph is going to look like. The red one that we see here is the original absolute value function. And the one that's in blue is when I put a value in front of my function. And people have a hard time looking at this and saying, well, is it vertically changing or is it horizontally changing? Because to me, it looks like it's getting pulled up. And to some, it looks like it's getting pulled out or pulled in. So which one is it? Is it vertical or is it horizontal transformations taking place here? Okay, I'm sorry, stretches or shrinks taking place. I'm going to pause this one for a second. And then let's take a look at this one. Now I'm going to animate this one, and you'll notice this one is a little different. It doesn't go down. Don't focus on the down right now. But notice that for this one, the value that's being changed is being changed on the inside of my absolute value. Not outside the absolute value, but actually inside. And this looks, to me, almost exactly the same. In fact, when I turn this other one on and I animate it, they look exactly the same. They act exactly the same. They go up and down and side to side. So the question always becomes, well, which one is it? Is it a vertical stretch? Is it a vertical shrink? Is it a horizontal stretch or a horizontal shrink? And it's really hard to perceive this in functions that you guys have all seen and are used to. So the first time that you actually are going to see this is when we do sinusoidal functions. This is the best animation that I can actually give you that actually demonstrates what is actually happening in our problem here. Okay. I'm going to label these so we can actually see them. Oops. Sorry. I want to make sure that these are labeled because I need them to pop on the screen to you. Okay. So when we're looking at, I don't need that upper one, and I don't need that lower one. Okay, what I need are those three that we see right there. So when we look at a sinusoidal function, this is a wave curve, and this is something we're going to do second semester when we start doing trigonometry. But you can see clear as day, there's a parent function here. Okay, I'm going to turn this off. So the parent function when we look at this is this green one. It's a wave pattern, and the wave pattern has a range of 1 down to -1. And when you look at this, we talk about the period of this. The period is how long it takes to get through an entire wave. So you can see it starts here at 0, it goes through an entire wave, and then it comes through to 6.28. Now these two numbers here should be familiar. We got 3.14 and we've got 6.28. That's pi and 2 pi, which we will talk about at a later time. When I turn the other graph on, I'm going to start it at 1 here so we can kind of see what's going to happen. Okay, whoops. Give me 1 second. All right, so let's turn that other graph on there, the blue one. I'm going to take, and by putting a value on the outside of my sine function, on the outside of it, we are basically saying I'm going to modify the y value. What does this look like? This is what it looks like when we're affecting the y value. Now look at the points 0, 0, 3.14, and 6.280. All three of those points are not changing. Side to side, my graph is not changing at all. My graph is getting taken and pulled in the upward direction and the lower direction because what we're doing is we're changing the y value. What do I mean? Well, when I look at this, I'm going to pause at 3 here. At this spot right here, my original graph, it was a 1, but now it's been pulled up to a 3. This has been vertically stretched by 3. When I take this and I move it down to a half, to 0.5, sorry, there we go, that has been vertically shrunk by half. So vertically stretched by half, vertically shrunk by half. When I animate this, you can see it's shrunk. I'm sorry, it's stretched. Now it's shrunk. It gets reflected because A is negative, and then it gets shrunk and then stretched, and so on and so forth, okay? So this is a vertical stretcher and shrink. Now I'm going to pause this one. Let's go up to the next one. On this one, the y is equal to sine of b of x. You notice that on this one, the b value is actually attached to the x. And because of that, what's happening is I'm going to be affecting the x value in this. So I'm constantly going to be changing the x value. What does this look like when I animate it? So when we look at this one, you can see my graph doesn't go up or down at all. It literally stays exactly the same. But those points that were snapped to it, the 0, 0, the 3.14, and the 6.28, they're constantly shifting in my picture, right? And we get the side-to-side thing going on. This is a shrink because it's getting compressed, it's shrinking. And then we do this when we pull it and it's getting stretched. So it's like imagine a spring getting pushed in, it shrinks, and then we're going to take it and we're going to go ahead and stretch it, okay? Well, let's talk about the numbers that are happening here. Here's when b is equal to 1. And this is the only one that is completely counterintuitive, and this is a struggle for people. As I take this B value and I move it, okay, the B value gets bigger. I'm like, okay, so there's a 2 there. That means it should be twice as, it should be like stretched by 2. That's the intuitive thing to do, is to say it's going to be stretched by 2. And that's not actually what happens. If you look at my green one, it takes 6.28 to get through an entire pattern here. But now when you look at this, if I go through the red, it goes all the way through this in 3.14. It now takes me half as long as it did before. By me putting a 2 in here, it now requires half. It shrunk by half. And so this is the caveat here, that whenever you're using a B value, it's always going to be the reciprocal effect is going to take place. That now that I've got 2 there, it takes half as long. It's a horizontal shrink by half. If I went ahead and made this into a 3, you'll see that what's going to happen is this 3 makes it shrink even more. And now you can see in this picture that I can go 1, 2, 3 waves in the same time it used to take the original one. And so this takes, right here, it goes through the pattern, it takes 1/3 the amount of time to get through a wave. So this is a horizontal shrink by a half. Versus when I go ahead and I move this to a half, go in the other direction. Well, what's the reciprocal of a half? Okay, a reciprocal of 1/2 is just 2/1. So that means that it should take twice as long. And if I look at the 6.28 that's right there, you can see the green one goes for 6.28, but the red one got stretched out. In fact, it's stretched out so far, if you look all the way over here where the red finally completes a wave, it is now over here at 12.56, exactly double the 6.28. So this gets horizontally stretched by 2. It gets stretched out, okay? That's the summary of this, the visuals. Watch it again if you need, but again, the notes itself, I will have a completed set of the notes online, so you can go back and kind of look at those as well, okay? That's it. You've got this. Don't forget to like and subscribe to my channel. You take care and have a wonderful day.